right, lesson 8.7 is factoring special cases. Okay, today you're going to factor some trinomials by reversing the rules for multiplying special case binomials that you learned in lesson 8.4. Okay? Any trinomial in the form a squared plus 2ab plus b squared, or with a minus 2ab, is a perfect square trinomial because it is a result of squaring a binomial. So like here we have a plus b times a plus b, that's squaring a binomial, a plus b quantity squared. That's going to give you those special formulas that we learned in the previous lesson, in one of the previous lessons, okay? So if we take a look at our rule here, you can see that the trinomial a squared plus 2ab plus b squared, that is a perfect square trinomial because the first term is squared and the last term is squared. Okay? So here's how you can recognize a perfect square trinomial. This is what you need to make sure you write down. Okay? The first and the last terms have to be perfect squares. The middle term is twice the product of one of the factors from the first term and one factor from the last term. So if you look at the examples up here, okay, x squared is a perfect square. X squared is a perfect square because x times x is x squared, right? 16 is a perfect square because 4 times 4 is 16, okay? Then, if we take one of the factors from the first one and one of the factors from the second one, that would be 4x, and then multiply it times 2, you would get 8x, okay? So, let's take a look at problem 1. Alright, so problem 1 says factoring a perfect square trinomial. Okay? So we want to know what is the factored form of each expression. Now when we do this, the first thing we have to do is identify whether or not it is a perfect square trinomial. Okay? So, we're going to look at the first term. First term is x squared. Okay? Is that a perfect square? Yes, because x times x is equal to x squared. Okay? Then 9. Is that a perfect square? Yes, because 3 times 3 is a perfect square. Okay? The next thing we need to check is if we get 6x, if we do the 2ab. So it's 2 times one of the first terms, one of the first factors, and times one of the second factors. So 2 times x times 3, that's going to give me 6x. That tells me that this is a perfect square trinomial. So now that you know this is a perfect square trinomial, you're going to take one of the factors from the first term, one of the factors from the second term. Since this is a plus 2ab, we're going to have a plus in our binomial. So we write x plus 3 quantity squared. There's an x right here, right? There's a 3 right here, and that goes right there, okay? All right, so again, we want to decide, is this a perfect square trinomial, okay? So we're going to look at the first term, x squared. Perfect square, yes? Because x times x is x squared. Then we want to look at the 49. Yes, it is. Very good. Because 7 times 7 is 49. Now we need to check our middle term. So we want to take 2 times 1 from the first term and 1 from the second. So 2 times x times 7 is 14x. So again, this is a perfect square trinomial. Now, you will take 1 factor from the first term, 1 factor from the second term, and then you will write your binomial. So we have x, and because it's a subtraction in the trinomial, it's a minus 7 quantity squared. And there's your binomials. Problem 2 is factoring to find a length. You're building a square patio. The area of the patio is 16m squared minus 72m plus 81. And we want to know what is the length of one side of the patio. Okay? So we're going to start with a square patio. There's our square patio. The area, of course, is length times width, and since it's a square, it's going to be side squared, right? Side times side, right? So area is equal to side squared, okay? And we're going to use this trinomial up here, okay? So we want to know, is the first term a perfect square? Yes, that is a perfect square because 4m times 4m is equal to 16m squared. So we have 4m squared, okay? You can write 4m times 4m if you want to, okay? And then we can check the second one, 81. 9 times 9, right? Okay. Okay. So now, we're going to check our middle term. So 2 times 1 of each of those factors up there. So 2 times 4m times 9. So 4 times 2, 2 times 4 is 8. Times 9 is 72, and then we have our m. So we do have a perfect square trinomial. Since we have a perfect square trinomial, now we can write our binomials, okay? So we're going to take one of those and one of those. All right, so we're going to take one of those each and write it into our binomial. So we have 4m, and because it's minus up here, right? Because it's minus up there, we want to put minus in our binomial, and then it's going to be minus 9, and it's quantity squared. So this is how I find the area of that patio. But what's the question? Right. It says, what is the length of one side of the patio, right? So this is 4m minus 9 times 4m minus 9. Very good. Just one of them, right? So, one side of the patio is 4m minus 9 units. Problem 3 is factoring a difference of two squares. So here, this is a difference. We know it's a difference because it's subtraction, right? And we have to see if we have perfect squares for A and B. Okay? Now, remember when we had the A plus B times the A minus the B, right? And then when we FOILed this, what happened? Do you remember what happened? We had the A squared, right? Then we had minus AB, and then we had plus AB, and then we had minus B squared when we FOILed it, right? So what happened to this? What happened to So what happened to this middle part? It canceled out, right? So we ended up with A squared minus B squared, right? So this, if you look at this, isn't it look like that? Yeah. Okay. So if I want to write this example A as the product of two binomials, it's going to be a plus something and a minus something. Is everybody clear with that? All right. So we can look to see if we have, well, we can see b squared and 100. We know those are perfect squares, right? So these are a difference of two perfect squares. So to find out what one of them is, you're going to take the square root of it. So for A, the square root of v squared is equal to v. Okay? For B, the square root of 100 is 10. So these two, this A and this B, is what's going to be in our two binomials. Okay? So we write our two binomials. We have the A, which is the V, so V times V. And then we have the B, which is 10. So there's the 10 and the 10. And one of them will be a sum, and one of them will be a difference. Okay? So this is your final answer. For example B, do we have two perfect squares? Yes, we do. So if we are going to, we're going to take the square root for A. We're going to have the square root of S squared. So that's going to be equal to S. Good. And for B, we have the square root of 16, which is equal to 4. Good. And now you're just going to take those and write it into your two binomials. Okay? So you've got the S and the S and the 4. And now one of them will be plus, addition, and one will be subtraction. Very good. So plus and minus. And there's your final answer. All right, so problem 4 is again factoring a difference of two squares. The only difference with this one and the one we just did is that we have a coefficient in front of the first term. It's the only difference. Okay? So we're going to find our A. So A is equal to the square root of the first term, right? The first term is 25b squared. So what is my A going to be? 5b. Very good. So my B is the square root of 64, which is 8. Very good. And now you just write it with your binomials. So we've got 5b times 5b. We've got 8 times 8. And one of them will be plus, and one of them will be minus. Okay? Now, remember that the signal that you can do this is that you have a difference of two squares. The A is a perfect square, the B is a perfect square, and it's a minus in the middle. If it says plus in the middle, you cannot follow this rule. Is everybody clear? Okay. All right, problem 5 is factoring out a common factor. Okay? When you factor out a GCF, factor out the GCF of a polynomial, sometimes the expression remains is a perfect square trinomial, or it could be the difference of two squares. You can then factor that expression further using the rules from this lesson. So, this is factoring a monomial out first. Because right now, is 12 perfect square? 12t squared, is that a perfect square? No. 48? No, it's not a perfect square. Those are not perfect squares, right? But look at what happens when we factor something out. So, what can I take out of a 12t squared minus 48? 12, right? So, we're going to factor out a 12. And you remember when you factor it out, where does it go? On the outside of the parentheses. Very good. So, we've got 12 times a quantity. Now, this is going to be t squared minus 4. Very good. So now you can see t squared is a perfect square. And 4 is a perfect square. So now this, we can follow the rule we just learned, right? So now we're going to look at our perfect squares, right? So t is a perfect square. So for A, we're going to have the square root of t squared, which is equal to what? T. Good. And B is going to be the square root of 4, which is equal to 2. Good. So now, because we have a difference of squares, we're going to make our two binomials. One's going to be plus, and one's going to be minus. Very good. So, we put the 12, make sure we bring down the 12, and we have t plus 2, and we have t minus 2. And there is your final answer. What am I going to factor out of letter B? We're going to factor out a 3. Very good. So the 3 comes out. What's left in the inside? 4x squared plus 4x plus 1. Very good. Now here, this is not a difference of squares, right? But this is like our example 1. Okay. So that means we have to check to see if we have the first term perfect square, the last term of perfect square, and we have to check our middle term if we get it by doing 2ab. Okay? So for the first one, what am I gonna multiply? Oh, let's just do A. A is going to be the square root of 4x squared. So that's going to give me what? 2x. And to get B, the square root of 1, which is 1. Right? So now we have to check our middle term. So the middle term we get by checking our 2ab, right? So 2 times a, which is 2x, times 1 is equal to what? 4x. Check. Right? So, now, this is a perfect square trinomial, and now we can write it using our binomials. So, we have to bring down the 3. Don't forget to bring down your GCF. And then the binomials are going to be made up with your A and your B. So A is 2x. So that's 2x times 2x like that. And your B is 1. So there's the 1 times 1. And then 1 is going to be plus And 1 is going to be, and then this one is going to be a plus also. So, if I want to write it with the exponents, this would be 3 times 2x plus 1 quantity squared. And there's your final answer.